Ever wonder how AI models like GPT or BERT truly learn language? It's not magic. It's all about training on massive text datasets. But here's the catch. If that text contains repeated or copied content, the model might appear smarter than it is. Today, we're diving into a revolutionary tool called INFINI-GRAM MINI, a game changer for uncovering hidden issues in AI training data. Let's explore how it works and why it matters. First, what's an n-gram? It's a sequence of words or characters, like machine learning or AI revolution. Exact n-gram search means finding identical sequences in text. But here's the problem: the internet is massive. Storing and searching petabytes of data is like trying to find a needle in a haystack, with a million haystacks. Traditional methods. They're slow and storage-heavy. One system required 29 times the space of the original data. That's impractical for the internet scale. Enter FMindex, a data structure that compresses text while enabling efficient searches. Think of it as a library where books are shrink-wrapped, but still easy to find. It stores only key parts of the text and uses math to reconstruct it when needed. INFINI-GRAM MINI takes this idea to petabyte-level datasets. It reduces index size to just 44% of the original corpus, like shrinking a 10 GB file to 4.4 GB. And it's fast, indexing 46 TB of internet text in 50 days on a single computer, or 19 hours with 75 computers. But why does this matter? Let's talk about benchmark contamination. Language models are tested on datasets like SCAD. Think of them as practice exams. INFINI-GRAM MINI found that up to 40% of SCAD data was already in internet crawls, meaning models might be memorizing answers instead of learning to solve problems. This could overestimate a model's true abilities. To tackle this, researchers created a benchmark contamination bulletin to track reused data. They also built a web tool, an API, so anyone can search indexes. It's like giving researchers a superpowered magnifying glass to peer into the internet's hidden corners. Here's where it gets critical. When testing AI, benchmarks like math problem sets or coding challenges can be leaked into training data. For example, a math problem from the AIME 2024 benchmark was published on AOPS, which was part of the training data. If an AI saw that exam before testing, it's not solving the problem, it's recalling the answer. Or take MMLU, a reasoning test. Researchers found documents where correct answers were hidden in plain sight, just not in the same order. That means models might be memorizing patterns, not thinking. And in GSM-8K, a math dataset, entire test examples were copied from Hugging Face, so the correct answers weren't even there to begin with. These issues fall into three categories. 1. Answers are present, like the AIME case. 2. Only questions exist, common in coding benchmarks. 3. No answers at all, like some big bench hard tests. Why does this matter? Contaminated benchmarks make AI performance look better than it is. If models are cheating by memorizing answers, we're not building smarter systems, we're building ones that play the game. So what's next? INFINI-GRAM MINI isn't just about fixing problems, it's about enabling new possibilities. From curating better training data to building specialized datasets, this tool opens doors for more accurate and ethical AI. If you're curious, check out their website, try the demo, or dive into the code. The future of language models might just depend on tools like this. Thanks for watching, stay curious, and let's keep exploring the internet's secrets together. Ever wonder how AI models actually learn? Or why some of their answers might not be as reliable as they seem? Today, we uncovered a critical issue: data contamination in AI benchmarks and how researchers are uncovering it. Let's start with the basics. When scientists test AI models, they use standardized benchmarks, like math problems, reading comprehension quizzes, or coding challenges. But what if those tests were leaked into the training data? That's contamination, when the answers to a test are already hiding in the data the model learned from. It's like studying for a test by peeking at the questions beforehand. Your score doesn't reflect real knowledge. In this study, researchers used a tool called FMindex to hunt for contamination. Think of it as a superpowered search engine for text. They fed it massive datasets like the Pile, DCLM, and Common Crawl, then checked if benchmark test entries appeared in those sources. The results? Surprising. Here's where it gets interesting. When you ask an AI a short question like a single word, it responds almost instantly. But as queries get longer, the time increases, still faster than older methods. The FMindex proved efficient even with huge datasets, handling long context without slowing down. That's a win for scalability. But the real eye-opener was the contamination problem. Researchers scanned benchmarks like math problem sets and common sense quizzes, and found dirty entries, questions or answers that literally appeared in the training data. For example, a math problem from the AIME 2024 benchmark was actually published on the AOPS website, which was part of the training data. If an AI saw that exam before testing, it's not solving the problem, it's recalling the answer. Or take MMLU, a reasoning test. They found documents where the correct answers were hidden in plain sight, just not in the same order. That's tricky because it means models might be memorizing patterns, not thinking. And in GSM-8K, a math dataset, entire test examples were copied from Hugging Face, so the correct answers weren't even there to begin with. These issues fall into three categories. 1. Answers are present, like the AIME case. 2. Only questions exist, common in coding benchmarks. 3. No answers at all, like some big bench hard tests. Why does this matter? Contaminated benchmarks make AI performance look better than it is. If models are cheating by memorizing answers, we're not building smarter systems, we're building ones that play the game. The good news. Researchers are fighting back. They've created an online contamination bulletin, where the community can report and track problematic datasets. It's a vital step toward cleaner, more honest AI evaluation. So next time you see an AI acing a test, remember, the real challenge isn't just solving problems. It's making sure the rules of the game are fair. Thanks for watching. If you want to dig deeper into how AI learns, or how we can make it better, hit subscribe. And let me know in the comments, what's your biggest AI mystery?